Back to QST, this is Arjun Shameer speaking, and I will be teaching you chemistry for this week. First of all, I apologize for being a bit late. Right, okay. Now, to start off with, we have finding pressure. Okay, so for this one, you have to remember that P1 V1 over N1 T1 is equal to P1, no, my bad, sorry, P2 V2 over N2 T2. Okay, so it's in the same container, so we can cross out N1 and N2. P1 120, P2 we don't know, and T1 and T2 stay the same, so we can cross that out too. V1 is 3 and V2 is 2. We can work with this, so we can say 120 multiplied by 3 is equal to 2 times P2, so that is 2P2 is equal to 360 divided by 2, you'll get 180. That is the answer for the first one here. Okay, yeah. Okay, now we need to find pressure again. Same rule here. Okay, P1 V1 over N1 T1 is equal to P2 V2 over N2 T2. Okay, so I have to say that the volume is equal, so we can cancel that out. N1 and N2, they're in the same container, unless and until they say it's not in the same container, do not change the moles. And now the only variables are P1, P2, and T1, T2. Now, you know, P1 is 120, P2, we don't know. Temperature 1 is 25, temperature 2, 125. Now, this is Celsius, so we always need to change it to Kelvin. And for that, we just add 273. So now we have 120 over 293 is equal to P2 over 125 plus 273, which will give you 398. My bad, not 293 here, 98. Okay, cross multiply. Now when we do it on the calculator, it's gonna be 20 times 398 divided by 298, we get 160.26. Round that off, we get 160. Alright, next one, same thing here, just a little bit of difference. Same rule, P1 V1 over N1 T1 is equal to P2 V2. Apologize for the bad handwriting here. And 2 T2. Okay. Now pressure stays the same. Cross that out. Temperature 100. It's Celsius or Kelvin. It's going to be 373. 373. And here it's going to be 473. And 1 and 2 crossed out. Okay, we have this one is 4, we don't know V2, so 4 over 373 is equal to V2 over 473. Again, cross multiply here, so 4 times 473 divided by 373, we get 5.072 to the nearest, to the 366, so that's 5.07. Alright, this one we're gonna be using a different rule, but same concept. Alright, PV is equal to nRT. Okay, this one we have pressure. Okay, we don't have pressure, my bad. We have volume, which is 3. we do not have the moles, but we do have the mass and the molar mass, so we can't find the moles. So to find the moles, N is equal to M over M. So we can do 0.0440 over the molar mass. It's H2 hydrogen. It's 2 H's, so it's going to be 2. We have to divide by 2, which will give us 0.022. Okay, R is constant. Now that's 0. They'll tell you that all the time. 0.08. 0.08, and temperature is 57, but we make it to Kelvin. So 273 plus 57 is 57. We get 330. Yes, 330. Okay, now we got everything we need to work with. We just need to find the pressure. So P times 3 is equal to 0.022 times R, this, and multiply that by the 330. Okay, so on your calculator, 0.022 times 330 times 0.08. Now we found that. Now we divide that by 3 to find the pressure. You find to be 0.1936. Yeah, sorry, here I made a mistake. So 0.1936, you round that off to 366, so 0.194. Now this is a definition that you all have to memorize. The process by which gas particles mix by colliding with each other, bouncing off in all directions, is known as diffusion, whereas escape of gas particles from a container through a tiny orifice is known as effusion. Yeah, that's like going through a hole. Okay, this one, all material. To find the number of moles, as we all remember, it is N is equal to M over M. Mass is 14.2. Chlorine is diatomic, so 70. You find it to be 0.2. Okay, so that's 0.2. And then moles of sodium chloride, we do MCR. So sodium chloride is 1 to 2, 0.2. We get 0.4 here when you cross multiply. Okay, and then here, sodium chloride, mass of sodium chloride produced. Mass is moles multiplied by the molar mass. So the moles is 0.4 multiplied by the molar mass. The molar mass is 35.5 and 23 combined because it's NaCl, so that's going to be 58.5. Okay, 0.4 times 58.5, you get 23.4. That's the mass of sodium chloride. Okay. Alright, okay, this one, same thing. N is equal to M over M. Yeah, N is equal to M over M. Mass is said to be, mass is 0.109. Mass is 0.109, so 0.109 over the molar mass of zinc, which is 65.4. We will get 0.109 over 65.4. We get it to be 1.666, so we round that off to 1.67 in scientific figures and scientific notation, significant figures and scientific notations. 1.7 times 10 to the power of negative 3. Okay, that's the number of moles of zinc. Now we need to find the number of moles of hydrogen. Again, we do MCR as usual. Now MCR is just 1 to 1, so it's going to be the same thing. It's going to be 1.67 times 10 to the power of 4. Times 10 to the power of negative 3. Okay. Now what do they want? They want the total volume of hydrogen gas released at RTB conditions, and they want it to be in centimeter cube. Now this is when we make it volume, we have to multiply. So 1.67 times 10 to the power of negative 3, make it to volume, we multiply by the RTB, which is 24 decimeter cube. So we get let's see, 1.67 times 10 to the power of negative 3 multiplied by 24, we get 0.04. Now that is in decimeter cube, we need to make it a centimeter cube, so we have to multiply that by 1000, we get 40. Okay, so yeah, that's 40 as volume. Same thing, n is equal to m over m, number of sodium metal reacted, number of moles, 4.6 gram of sodium metal, so 4.6 over the molar mass of sodium molar mass is 23, so that's 4.6 divided by 23, we get 0.2. They want the number of hydrogen gas released. The MCR is 2 to 1, so it's 0.2. This is going to be cross multiplication, 0.1. Okay, now choose the heavier gas. We have the rate of diffusion given for a gas X and hydrogen chloride. They want heavier gas, so you have to remember, the heavier, the slower the rate of diffusion. It's common sense, the more heavier something goes, the slower it will be. So over here, the slower rate of diffusion is gas X, so that is the heavier gas. Now to find the molecular mass for gas X, we have two rules. I'd like to tell you them. We have, just to change the color, it's pink. I don't really like pink. Okay. Molecular mass. Okay, so rate of diffusion 1 over rate of diffusion 2. So rate of diffusion of gas X is 0.63 over 0.87 is equal to radical the whole thing, the molar mass of both. Now we know that the molar mass of hydrogen chloride, as per given here, is 36.5. So over here will be the molar mass of the second gas, so that will be 36.5 over X. Okay, so that is, okay, wait, there is another rule that I like to use, because this one here in this scenario is a bit complicated. So I'd like to introduce you to that rule. It will be not this again, 0.63 squared over 0.87 squared is equal to the molar mass, so that is 36.5. To me, this is much easier for this scenario. Okay, now we just do the cross multiply. 36.5 multiplied by 0.87 squared, we get 27.62, and then just divide that by 0.67 squared, we get 63. Divide by 0.63 squared, we get 69.606. They wanted it rounded to 366, So that's going to be 69.6. Okay. Now this one, increasing order of rate of diffusion. Now, as we said, the heavier, the slower. So CO2, carbon dioxide, that is 16, yeah, 12 plus 16 plus 16. The molar mass of CO2 is in total 44. Yes, 44. And HCl will be, as we know, 36.5, and 44, 36.5, and this one H2O will be hydrogen is 2, yeah, and oxygen would be 16, so that's 18. So when we do it in increasing order of rate of diffusion, they want from slower to faster. So the heavier one will be slower. So 44 first, so CO2, and then HCl, and then H2O. That is the order. 44, 36.5, and then 18. Okay, next question. Two gases, A and B, injected opposite ends of a glass tube. Okay. The color stain is the orange part. Now, as we see, gas A and gas B are from both sides, and then that's the color stain. So the faster one to reach the color, like when they collide, it's definitely gas A, because it's going at a faster rate and it has reached a further distance than gas B has. So gas A is more faster, and that is why it is lighter. Now, the phenomenon responsible for this is diffusion. As we said, they collide with each other and react. Right. Okay, this is also a definition. Volume occupied by each gas is equal to the total volume of the vessel. Yes. Now, this is back to what we used to do before. P1 V1. So P1 V1 is going to be pressure 50 times 6 over N1. We cancel out because it's in the same container, and temperature 177 plus 273, that's going to be 450. Okay, is equal to 100 times V2 over, we cancelled out N2, and that is 627 plus 273, that leaves us with 900 here. Okay, we cancel out 100, 950, and 451, 919. Okay, so that is basically 6 over 9 is equal to V2 over 9. So that is V2 is the same as V1, so that is 6. 366, 6.00. Okay. Okay, now this one, number of moles of oxygen gas needed to react completely with 0.5 moles of butane gas. We do MCR, like straight up MCR. So we have butane gas, which is 2C and oxygen gas, which is 1302. 2 to 13, 0.5, cross multiply, we get 3.25 here. Okay. I'll find the volume of oxygen gas needed to react completely, 0.5 moles. Okay, volume. So we found the moles of oxygen gas. We just multiplied 3.25 by the RTP condition, which is 24. We get 78. Yeah. Right, again. Now, they want air is 20% oxygen gas. Find the volume of air needed for the given sample of butane to react completely. So air is 20% oxygen gas, just multiply it by 5 to make it 100%. Okay, that's it for this one. This one is aluminum reactor. Okay, same thing. Number of moles of aluminum in the given sample. We have N is equal to M over M again. So mass, which is 108 kilogram. We make it into grams, of course. 108, put that in your calculator, divided by molar mass, which is 27. 108 divided by 27. We get 4,000. Okay, that is for part A, number of moles of oxygen gas consumed. Now we do MCR here. Again, MCR, that is 4 to 3, 4,000, cross multiply, you'll end up with 3,000. Alright, okay. Now, part C, calculate the mass in kilograms of oxygen gas consumed by the reaction. Okay, oxygen gas consumed. Wait, let me see the reaction again. Okay. We have the number of moles of oxygen gas. We just need to find the mass, which is going to be M is equal to moles times molar mass. So 3,000 multiplied by the molar mass, which is 16 times 2 because it's diatomic. 32, 16, okay, so 3,000 multiplied by 32, we get 96,000, but then that's in grams, so we need to make it kilograms, divide by 1,000, so we get 96 kilograms to 4 6 figures, 96.00. Okay. Balancing, just balance it out, and I'm pretty sure all of you know balancing. Now, how many moles of chlorine are needed to produce 6 mole of iron chloride? We did MCR here. Chlorine, which is 3, to iron chloride, which is 2. Okay, 6 moles of iron chloride. We do cross multiplication. 6 times 3 divided by 2, we get 9. Yeah, that's it. 9 moles. Okay. This one. What is the temperature in Kelvin of negative 273 Celsius? So when you make it from Celsius to Kelvin, always add 273. Okay? So negative 273 plus 273 is 0. And size in Kelvin of 1 Celsius. Okay, what they mean is when we change the Celsius, like when we increase it by 1 or when we change it by 1, the Kelvin will also change by 1. It's proportional. The change is always proportional. That's what they want to ask you. So the size of 1 Celsius is equal to the size of 1 Kelvin. Alright? They don't want you to find the amount of Kelvin of 1 Celsius. No, they just want you to find the size of 1 Celsius that is equal to Kelvin. So that's 1. That's all. Hope you guys can do the exam well. Good luck.